Hi everyone. Today in our lecture video we are going to study the comparison between the formulas of Laplace transform and inverse Laplace transform and how to get the formula of inverse Laplace transform from Laplace transform. So here we are going to have an understanding between the Laplace and inverse Laplace transform formula. So f of t is our function. Here will be the Laplace transform formula. F of s will be using the inverse Laplace transform. So in my last video you can check what are the formulas of Laplace transform. So the function is f of t. So L stands for Laplace of f of t and it is integral 0 to infinity e power minus st f of t dt. On integrating, this becomes f of s. That means initially the function was t, it is transformed to function s. So we can clearly write Laplace transform of the function will be f of s. Now to get the inverse Laplace transform, this will be the key formula for us. Just you have to shift this transform to the RHS. That gives inverse Laplace transform. For the Laplace transform, your function will be f of t, solution will be a function of s. For inverse Laplace transform, your function will be f of s and the solution will be f of t. So just rewrite this in the inverse form. Take L on the other side, we get L inverse of function f of s gives back the function f of t. That is what we call inverse Laplace transform. L of f of t is f of s is a normal transformation. Inverse is your function will be in terms of s, the solution will be in terms of t. So f of x is your function. Applying inverse Laplace transform. L inverse represents it's an inverse Laplace transform. So function is f of s. When you apply the transformation, the function s is transformed into function t. So if suppose a function, instead of function, if I have a constant, so we have already defined Laplace transform of a constant is constant by s. You can see your function is a constant, solution will be a function of s. Okay. So let us come back to the function f of s. If suppose your function is a by s, make sure the denominator is greater than 0. If your function is a by s, just compare with it. If Laplace transform a is a by s, its inverse will be, that is L inverse. Take this L on the other side. So L inverse of a by s will be equal to a. Similarly, whenever your function is an exponential, Laplace transform of e power at is 1 by s minus a. You can see it is a function of s. This function you take it here. If suppose you have 1 by s minus a as your function, then inverse of this, that is L inverse of 1 by s minus a. Shift this transform to other side, your answer will be e power at. Similarly, e power minus at, Laplace transform e power a minus at is 1 by s plus a. If suppose you have 1 by s plus a as your function, then its inverse transform will be, shift this Laplace to another side, so it is e power minus at. You can see your functions are s and your solution are in terms of t. If suppose the function is a cos at, as I already told you in our last video, cos comes, your transformation will have s in the numerator and denominator is s square plus a square. If suppose in the function you have s by s square plus a square, directly transform here. Shift this L on the other side, so L inverse of s by s square plus a square, we get it as cos at. Take the function of sin at. If sin appears, a should come in the numerator divided by s square plus a square. Now if suppose your function is having a by s square plus a square, Take this L on the other side, so that becomes L inverse of the function. That is what we require, L inverse of A by S square plus A square, that can be written as sin 80. Similarly, we can write it for hyperbolic functions. I have written for the hyperbolic function, cos appears, S comes in the numerator. If it is hyperbolic, you get negative sign. If it is sine function, A appears in the numerator and hyperbolic negative sign. So whenever you have the function of this type in inverse, shift this L to the RHS. So it becomes L inverse. So the function here will be the solution for the inverse Laplace transform. So now we have a function where the power of the variable is a constant. Here we have two categories. One when n is positive integer, right? That is very important. This you can apply only when it is positive integer, and this is for negative integer as well as for rational numbers. Okay. So whenever you have this form, your transformation appears. So here one small change is n factorial and gamma n plus 1 treated to be a constant. So we will write here 1 by Sn plus 1, and you can use 1 by Sn plus 1 when n is positive. Okay, as just see here, t to the power n, take this n factorial to denominator. So L inverse of 1 by S power n plus 1 will be t to the power n by n factorial. That's it. Similarly, if you have 1 by Sn plus 1, same, but in this case the value of n will be negative and rational form. Okay, in that case L inverse of 1 by Sn plus 1 will be, shift this gamma of n plus 1 to the denominator. So t to the power n by gamma of n plus 1. So this is how you have to compare the transformations and inverse transformation. It's better to learn the transformation. Inverse you can automatically get by transforming the functions. So now let us have a comparison of product of functions. Whenever you have a function with exponential, function with trigonometric, function of inverse form, right? So we'll have a comparison between both of that. So first one is, whenever you have a function multiplied with exponential, that is e power 80 into f of t. So whenever you have an exponential multiplied with the function, our transformations will be Laplace transform e power 80 f of t, that is equal to f of s minus e. Right? So L inverse of f of s minus a is our function. Just compare with this. Shifting this inverse on this side, what is your answer? E power 80 into f of t. That's it. Now if suppose you have a product of polynomial into function, which we have already stated, polynomial to function transformation is minus 1 power n d power n by ds power n into f of s. Okay, this is nothing but nth derivative of the function. So if suppose I have nth derivative, that is d to the power n by ds power n into f of s with a negative sign. Okay, or you can write minus 1 power n into f power n of s, which indicates it's the nth derivative. So take inverse, that means you are shifting this L on the other side. So L inverse of minus 1 power n f power n of s will be equal to t to the power n into f of t. This negative side you can take it on either side because depends on your n value. Next we have integration. After the differentiation we have integration, that is ranging from 0 to t f of t dt. Laplace of integral 0 to t f of dt is nothing but f of s by s. Okay. Now take the Laplace on the other side, so your function will be f of s by s. So function is f of s by s. So L inverse of f of s by s is equal to, take this inverse, so you'll get this function. So this is treated to be 0 to t f of t dt. So this is all about the comparison of Laplace and inverse Laplace formula. So my opinion is this: learn the Laplace transform formula thoroughly. Transformation is very easy. Based on your function, you need to shift the transforms and get the function in terms of t. I hope this concept of finding Laplace and inverse Laplace is clear to everyone. We'll meet in the next video. Thank you everyone.